Power in AC Circuits by Aidan Ragasa. Here's our table of contents. We have the abstract, introduction, an AC circuit example, our physical principle, our analogy, another analogy slide, and also a revision slide. Abstract. What is AC current? Alternating current, AC, circuits are preferred for electricity transmission due to the ease of changing voltage levels. AC power facilitates efficient long-distance electricity transmission. Complexity of AC power. Unlike direct current, DC power, AC power involves real power, the actual power consumed by resistive components in the circuit, reactive power, power stored and released by inductive and capacitive components, apparent power, the combination of real and reactive power. We also have power factor. It's a crucial concept for AC circuits, represents the efficiency of power usage, defined as the ratio of real power to apparent power. A higher power factor indicates more efficient utilization of electrical power. Introduction. What are AC circuits? The concept that I am covering is power in AC circuits. AC circuits, also known as alternating circuits, are used because the voltage is easy to change into higher or lower values. This means that transmitting electricity long distance can be made more efficient. AC power is more complicated than direct current power. It's more complex because it involves things like real power, reactive power, and apparent power. The key concept for AC circuits is the power factor. This shows the efficiency of power usage and is a ratio of real power to apparent power. Here's an example of how AC circuits differ from DC circuits. Look how AC current flows compared to DC. This slide goes over the physical principles of AC power. So we see fundamental equations for power, key physical laws, and types of power. I'm going to leave this on screen for a second or two, just so you could read through the equations. You can pause if you like. For my analogy, I think a water wheel is a good analogy for my topic. A good analogy I came up with is water flowing from a river spinning a water wheel. As the river water flows onto the water wheel, it causes it to spin, generating power. Real power is pretty much the effective power of the water wheel. If it does something like grind up wheat, for example, it would measure the actual work being done by the power outputted by the water wheel. Reactive power can be like disturbances and inconsistencies in the water that take up power but do not contribute to turning the water wheel. Apparent power is the total amount of power going through the system, which can be like the total amount of water flowing through. It is the combined total of real and reactive power in the system. In my analogy, the power factor would be how efficiently the water wheel converts the flowing water into usable work. A simple at-home water wheel experiment could be made to demonstrate power in AC circuits. You could do this by 3D printing the water wheel and using a hose connected to a water source to make it spin. You could then use a cheap laser tachometer to measure the RPM of the water wheel, and therefore measure its output. Thanks so much for watching, and I hope you enjoyed my video. My last slide today is the revision slide, which is basically what I changed from the drafts. For that, I've changed a bunch of formatting. I added the abstract slide, and I've made a ton of small and big changes to my assignment. Thanks for watching.